In this video, we will be looking at titanium cracks underneath layers of titanium. On the left, Miz-21B. On the right, Miz-21C. And the probe I have hooked up to the Miz-21B is a very small pencil probe that was used on F-16 fighter aircraft. And I'm operating 2 megahertz on the Miz-21B. And for my test material, those are sheets of titanium, 5 sheets, 4 thousandths inch thick each one. So they're brought together to simulate an infinitely deep crack. So on top of that, the first thing I'm gonna do is just scan the open crack with the Miz-21B. And we're not even gonna mess around with the Miz-21C because finding a surface crack is not challenging for either instrument. But I'm not going to be able to find the really deep stuff with 2 megahertz with this particular probe. So first thing I'm going to do is just scan across that surface breaking notch. And we're going to look at the Miz-21B. And I might have to null it. Let me hit the balance. Okay, so nobody's going to dispute. That one's pretty easy to see, right? Now I have to find what I do with my shims. These titanium shims are 4 thousandths thick. So I'm just going to put my first shim on top of that crack, and then I'm going to rebalance. And look at the Miz-21B. Boom! Straight up. So very good detectability with 2 megahertz when the crack is only 4 mils below the surface. Now we're going to add on a second layer, titanium. And watch how rapidly the detectability goes down. So you have increased phase there, but your amplitude is about half the size. And then I'm going to stick on a third shim. And guess what? Maybe you can guess what's going to happen. Nothing. That's what's going to happen. It's basically non-detectable. So 2 megahertz with this tiny pencil probe, you can detect very deep cracks subsurface if they're only 8 mils below the surface. So that doesn't give you much of a depth-based inspection. Basically, you're finding stuff very close to the surface or maybe a little bit below. Now, to switch over to the Miz-21C, this one gets a little more interesting because if you look at my sample, you know, there's not much material on the top of this titanium plate, but this titanium plate is at least probably 5 millimeters thick. I mean, that's about as thick as you can go with eddy current, conventional eddy current, that is. But for the Miz-21C, I'm not even gonna mess around with the surface crack. I'm just gonna flip the block over, and then instead of using 2 megahertz, I'm gonna use 2 kilohertz. Now, dropping the test frequency on the Miz-21B down to 2 kilohertz isn't going to do anything for us because probe size or coil diameter has just as much to do with depth of penetration, probably more so, than does the test frequency. So just trying to drive a tiny coil at a real low frequency to get deeper depths isn't going to get you very far. But if you take a nice wide coil like you have here in the sliding probe, this is a Zetec sliding probe traditionally used for rows of fasteners on aircraft, but we can also use it for this little test. But, you know, those things are, I don't know, 3/8 of an inch wide at least. There's 2 of them, and they're operating the driver pickup mode, and we're at 2 kilohertz. So we're just going to scan this plate that's very thick when eddy currents are concerned. And first thing I'm going to do is scan along the edge of the titanium this way so there's no flaws. So let's just watch your screen now. I don't want to get any edge effect there, but as I'm scanning back and forth, we're not seeing any cracks. That's just edge effect. Don't get excited. But now what I'm going to do is come over here, place the probe on good material, and watch what happens when I go over that crack. And again, that's very deep, and I'm getting good amplitude on it. I guess all I could do now is slap a few more sheets of titanium on the backside and see if that even challenges our detectability. I doubt it. Nope. You can see the flaw like nothing. Where the heck is the rest of my titanium? Oh. So here I have 1, 2, 3, 4, 5. So this is 20 mils of extra titanium that I'm going to add to the back of this 5mm thick titanium block. Well, you can see our null point shifted a little bit, but it still finds that crack, no problem. So wide coils, driver pickup, low test frequency, you can have some really good penetrating power. So this is crucial that if you're going to be doing subsurface inspections that you use, you know, multi-frequency instrument where you can test at the surface with high sensitivity or down deeper with adequate sensitivity. You just got to use different frequencies, you know, and the right kind of probe. So I hope you enjoyed the video.